Hello to all the Form 5 students. Today I would like to discuss with you one of the most popular questions in the coming SPM exam. Let's get started with the class. Sub-practice 7.2c. A ball manufacturing factory needs to regulate the internal air pressure in PSI of the produced ball before being marketed. The frequency table below shows the internal air pressures of 50 ball samples taken from machine P and machine Q. Now let's see how to answer the next question. The factory specified that the internal air pressure of a ball should be between 11.3 psi to 11.7 psi. Which machine shows better performance in terms of air pressure accuracy? Okay, we need to analyze the data by finding the midpoint for the both machine P and machine Q. Now let's find the midpoint. Okay, so 8.0 to 8.9. The midpoint is lower limit plus upper limit divided by 2. So we get 8.45. So from 8.0 plus 0.45, we'll get 8.45. That means for the next midpoint should be lower limit plus 0.45, which is 9.45. And then for the next one is 10.0 plus 0.45, which is 10.45. So we will plus 0.45 for every lower limit. And then for the next one is 11.0 plus 0.45. And then 12.0 plus 0.45, right? So we need to write the midpoint first by adding 0.45 for every class interval by using its lower limit. So 12.0 plus 0.45 will produce 12.45. And then 13.0 to 13.1, we will get the midpoint will be 13.45. So we have found all the midpoint. Now we need to use a midpoint to find the mean for both machine P and machine Q. Still remember how to find mean for the data in so-called group data? We have the class interval, so we have to find a midpoint, and we time with the frequency, and then we plus another midpoint times with another frequency, plus so on and so forth over total frequency, right? So let's write down the total samples. The total samples for machine P and machine Q are for 50 balls are 50, right? So total sample is 50. Total sample means total frequency. Frequency and number of the balls are actually same. So we do machine P first. Let's find the mean for machine P. So for machine P, we will write down machine P first, and then we will write mean. Mean is equal to, we will take the midpoint times the frequency, or you can say frequency times the midpoint, the same, because you multiply frequency times the midpoint or midpoint times the frequency will produce the same answer, right? So you see the blue one and the green one. We will multiply one by one and plus them. Let's see, we are going to times 7 multiplied by 8.45 plus 11 times 9.45 plus 13 times 10.45 plus 12 times 11.45 plus 5 times 12.45 and then plus 2 times 13.45 over total frequency, which is 50, right? The total samples, it was given in the question 50, so we will divide by 50. For the mean, we need to divide by total frequency. So the mean is, after we press the calculator carefully, is 10.51. 10.51 is the mean for machine P. Now, after finding the mean, we need to find the standard deviation. The standard deviation is actually square root of the variance. Alright, so let's write down the formula for the variance is summation of the frequency times with the midpoint square, and then we plus one by one. Summation means we plus, so we copy down the blue and the green, and we will square the green one. The midpoint have to be square, right? Remember that you have to put bracket for the midpoint and square. Alright, only midpoint square. Frequency no square, okay? So you need to press your calculator slow and steady, carefully. So you are still dividing by 50, which is a total frequency. So let's press the calculator. 7 times 8.45 square plus 11 times 9.45 square, and so on and so forth. And then after that, we need to minus the mean square. Don't forget, minus 10.51 square. Right? Also, don't forget to square root the whole thing. Right? That is called standard deviation. So please do it carefully. Press the calculator 2 times to get the same answer, so that the standard deviation is accurate for the machine P. So alright, so after you press the calculator, the standard deviation is 1.33, right? The standard deviation is 1.33. So you can always double check your answer so that the answer is accurate. Now we are going to do the same to machine Q. We are going to find the mean and standard deviation. Before that, let's write down the mean for machine P is 10.51, and the standard deviation for machine P is 1.33. So let's proceed to machine Q. We are going to find mean for machine Q and also standard deviation for machine Q. So let's copy down the frequency and the midpoint. For the mean, machine Q is equal to, let's focus to machine Q. We have 1, 3, 5, 20, 18, and 3. We are going to take this frequency, multiply by the midpoint square 1 by 1, and we plus, and we are going to divide by the total frequency. So we take the blue one, which is the frequency, times the green one, which is the midpoint, over total frequency, which is 50. So the mean is, we will multiply 1 times 8.45 plus 3 times 9.45 plus 5 times 10.45 and so on. And then we will divide by 50. So we will press the calculator to find out what is the mean for machine Q. It seems like machine Q is having the mean, which is 11.65, compared to P is 10.51. Now let's work out the standard deviation for machine Q. So we will do the same like just now. We will take the frequency, which is in blue color, multiply by the midpoint square, okay, only midpoint square, 1 by 1. Okay, we will take 1 times 8.45 square plus 3 times 9.45 square plus 5 times 10.45 square plus 20 times 11.45 square plus 18 times 12.45 square plus 3 times 13.45 square. And then we divide by total frequency, which is 50. And then we need to minus the mean, which is 11.65 square. So we will minus 11.65 square. So now we can square root the whole things to get the standard deviation for machine Q. Right? So let's press the calculator carefully to get the answer. For the standard deviation is 1.04 for machine Q. It seems like the standard deviation for machine Q is much more smaller compared to machine P. So we'll list out for both of the machine, P and Q. The mean for Q is 11.65 and standard deviation is 1.04 for Q. If we compare the machine P and machine Q, is having different mean and standard deviation, and machine Q shows better performance in terms of the air pressure accuracy due to smaller standard deviation. So in order to choose the better quality, we have to choose the smaller standard deviation, which is machine Q, right? Because as you can see, standard deviation for machine Q is just 1.04 compared to machine P, which is bigger, 1.33. So machine Q shows better performance in terms of air pressure accuracy, because the range also, as you can see, 11.65 is actually should be between 11.3 and 11.7 between 11.3 to 11.7 as given by the question. So the mean lies within the range, fulfill the condition given. And beside that, beside the mean lies within the range, we can also see that the standard deviation is just 1.04, is the smaller standard deviation compared to 1.33, right? This implies that it is more consistent. So the smaller the standard deviation, the more consistent the data is. So in exam, you must write down the important keywords. Example, machine Q shows better performance. In terms of air pressure accuracy, because the mean lies within the range and the smaller standard deviation is very important. The smaller standard deviation implies that it is more consistent. Please remember the keywords. This is very important and very popular question in the coming SPM exam. That's all my sharing for today. Till then, bye-bye. I shall see you in my next video lesson. Bye-bye and have a nice day.